Welcome to the session 2 Laplace Transforms. In the session 1, we discussed about the introduction to process dynamics and control and basic concepts of control system. In the session 2, mainly we are going to discuss about the Laplace transformation. What is the role of Laplace transforms in the process dynamics and control we are going to discuss. So let's begin with the introductions. So now, what is the role of Laplace transformation in the process control systems? We know in the process dynamics and control system, we have a process. There will be a relationship between input and output variable. So in the process control system, the real process will be converted into set of mathematical equation by using a basic law of energy conservation or law of mass or etc. So in that equation, it will be in the form of ordinary differential equation. So the Laplace transformation is one of the techniques to solve the ordinary differential equation. So that's why we are studying a Laplace transformation in the process dynamics and control system. And there are other tools are there like Simulink, MATLAB and other tools are there to solve ODE. Like that, the Laplace transformation also one of the tool to solve ordinary differential equations. So the ultimate aim of studying Laplace transformation in control system is to solve the ordinary differential equation. Not only that, if you have a process, the model can be developed. The relationship between input and output variable model can be developed by using the Laplace transformation techniques. Then one can qualitatively analyze the chemical process by applying a Laplace techniques. So this is the reason why we are going for the Laplace transformation in the process dynamics and control system. So let's begin with the definition of Laplace transformation. So if you take the function f of t is the simple function, then Laplace for transform of that function is capital F of s. Just f of t, it will be in the simple function, it will be in the form of t, but Laplace transform of that function will be in the form of f. Yes. Okay. So what is the definition of Laplace transformation? The L of f of t. What is L here? L is nothing but the Laplace operator. L of f of t is nothing but integral 0 to infinity f of t e power minus st into dt, where the given condition that t should be greater than 0. So why the condition t should be greater than 0? Always everyone you heard about the negative temperature. There is a negative temperature, right? If you go to the hill station and all, -4, -6 degree negative temperature will be there. But you never heard about the negative time, right? Anywhere you heard about the -2 minutes or minus? No, it is not there. So the time vary from 0 to infinity. So that's why the time should be always here positive or greater than 0. That's why the condition given here. So before going to start the Laplace transformation, one should remember the formula, that is integral 0 to infinity f of t into e power minus st into dt. That formula you should remember. So now we'll see the Laplace transform of the some simple function. Okay, so what is the Laplace transform of the some simple function we are going to discuss? Take a first function, take a simple function f of t is 1 here. We know already what is the formula of Laplace transformation, that is integral 0 to infinity f of t e power minus st into dt. Here the instead of f of t, just you are going to substitute 1 here. Just substitute 1, you will get e power minus st. This is by actual normal integration, just integrate it, e power minus st divided by minus s you will get. So apply a lower and upper limit. If you are applying a lower and upper limit is infinity, e power minus infinity. Always e power minus infinity is 0, but e power plus infinity is infinity. So e power minus infinity is 0, e power minus 0 is 1. So here 1 by minus n, you can minus s, you can take it outside. Minus into minus, it will give you a plus. So 1 by s is the answer for if you take a simple function f of t is 1. So the Laplace of a simple function 1 is nothing but 1 by s. You can see if the simple function it will be in 1, but the Laplace of that function will be in the form of s. Let's take the other function f of t equal to e power at. So this e power at is known as the exponentially increasing function. We call it as a exponentially increasing function. Now just try take the formula of definition of Laplace transformation. In that definition, instead of f of t, just substitute e power at. Now look at the equation here. The base are same, so you can add the power. So take minus outside, s minus a into t you will get. Now just you do a integration. If you are going for a integration, you will get the answer like. So now apply a lower and upper limit. If you are applying a upper limit, e power minus infinity, again it's becoming 0. If you are applying a lower limit, 1 you will get. So 0 minus 1, minus into minus, plus you will get. So 1 by s minus a. So what is the Laplace of a simple function e power at is nothing but 1 by s minus a. Now go to the another function e power minus at. What is e power minus ac? This is exponentially decreasing function. Take a definition of Laplace transformation. In that definition, instead of f of t, just substitute e power minus at. Now again take the base are same, so you can add the power. Just go for the normal integration. In the integration, just substitute upper and lower limit. You will get the answer. The Laplace of e power minus at is 1 upon s plus a. You can see the difference. If you take e power plus at, the answer is 1 minus s, 1 by s minus a. If you take e power minus at, 1 by s plus a. Now go to the another function. Take the function f of t is t. If you take f of t is t, in the Laplace definition, just substitute instead of f of t is t. But this integration is not that much easy. It's not a normal integration. You can integrate by u integral u dv formula only. Now the given formula you can convert it into u dv format. So this is by experience only you can convert into u dv format. So you know the what is the integral u dv formula, you know. Okay. So what is u here? T, du is dt, v is nothing but within the bracket what it is there, we can take dv v, then dv is you can take like this. Okay. Now what is the formula for integral u dv? Integral u dv is nothing but uv minus integral v du. So just substitute in that format. Now you take a first part here. Here if you are applying a upper limit also, e power minus infinity becoming 0. If you are applying a lower limit also, instead of t it becoming 0. So the entire first part get cancelled, only you will get the second part. The second part, just integrate it, apply a lower and upper limit, you will get the answer of 1 by s square. So if you take a simple function t, the Laplace of that function is 1 upon s square. So you can go to the common t power n format. If you have a t power n, the Laplace of t power n is nothing but n factorial divided by s power n plus 1. So the any t square or t3, any simple function, you can find out the Laplace of that function. So now we can go to the Laplace of some simple trigonometric function. Take Laplace of sin at. Actually the sin at is nothing but imaginary part of Laplace of e power iat. Okay. So what is the imaginary, we know what is the Laplace of e power iat, that 1 by s minus ia. Okay. So what is the imaginary part of 1 upon s minus ia? But it is not in the form of a plus ib, or real and imaginary part are not splitted here. In order to convert into a plus ib form, just change the sign in the denominator and multiply and divide by the same value. Okay. So here you are going to multiply and divide by s plus ia. The value will remain same. So now in this here, look at the denominator. It will be in the form of a plus b and a minus b. You know what is the answer for a plus b and a minus b? That is a squared minus b squared. But here the I squared is there. I squared becoming minus 1. So here you will get the plus sign. So what is the imaginary part of this? That is imaginary part is a. So a upon s square plus a square. So that is the answer for Laplace of sin at. Laplace of sin at is a upon s square plus a square. So I think the same thing we can solve by some alternative method also. What is the alternative method? We have the formula for sin at in terms of exponential form. So this is a formula for sin at. So just substitute the sin at formula in the Laplace transformation definition. Here just substitute, then multiply with the e power minus 8 st and take the common thing. you will get the final value like. Now again you integrate it. So after integrating, apply a lower and upper limit, you will get the form like that. Okay. So again in the denominator take LCM, then S and S will get cancelled, only IA will be there. In the denominator already 2IA is there, so it will get cancelled. The final thing you will get A upon S square plus A square. So this is the alternate method you can solve Laplace of sin AT. Now go to the Laplace of cos AT. What is the Laplace of cos AT? That is nothing but the real part of Laplace of e power minus IAT. So what is the Laplace of e power minus IAT? Already we know 1 upon s plus IA. So now in this, take the real part. So in order to get into a plus ib form, just we are changing the sign, then we are multiplying, dividing by s minus ia. So if you are going, then in the denominator you will get the form of a plus ib and a minus a plus b into a minus b form. You will get the a squared minus b squared. I squared is there, that will become minus 1. So you will get plus sign here. So the real part of this formula is nothing but s upon s squared plus a squared. So the Laplace of cos AT is s upon s squared plus a squared. You should know the difference between sin AT and cos AT. And if you have a sin AT, a will be in the numerator. If you have a cos AT, s will be in the numerator. Same thing, you can go with the alternate method. We have the formula for cos AT. So the cos AT in terms of exponential form is given as e power IAT plus e power minus IAT divided by 2. So now substitute this value into the Laplace transformation formula. Here again you multiply with the e power minus st, then take a base as common, then add the power. If you are adding a power, you will get the form like that. Now you go for 1 by 2, you can take it commonly. You can go for the integration individually, then apply a lower and upper limit. If you after applying a lower and upper limit, you will get the answer as s upon s squared plus a squared. So this is the formula for cos AT. So like that, we can go for the hyperbolic function sin HAT. What is the Laplace of sin HAT? So the sin HAT can be given as e power AT minus e power minus AT divided by 2. Just substitute this sin HAT value in the Laplace transforms definition. Here multiply with e power minus st, you will get the form like that. So after that, you take a common base, then add the power, go for the integration, then apply a lower and upper limit. If you are applying upper limit, always you will get a 0. The lower limit is 0, so you will get 1 here. So now look at the denominator. It will be in the form of a plus b into a minus b. It will be a squared minus b squared form you will get. Again you solving, the 2 get cancelled. You will get a upon s squared minus a squared. So now what is the Laplace of sin HAT is a upon s squared minus a squared. Same thing, what is the Laplace of cos HAT? That is cos HAT formula, we can take it as e power AT plus e power minus AT divided by 2. Just substitute the formula into the Laplace transfer function formula, and then multiply with e power minus st inside. You will get the form like that. Now take 1 by 2 outside, then integrate it individually, apply a lower and upper limit. If you are applying upper and lower limit, the upper limit answer you will get 0, the lower limit answer 1 by s minus a plus 1 by s plus a. This will be in the denominator will be s minus a into s plus a plus b into a minus b form. Again you take it in the denominator s squared minus a squared. If you take LCM, you will get the form like that. Now the final answer you will get s upon s squared minus a squared. So what is the cos HAT? S upon s squared minus a squared you will get. Okay. So these are the some of the Laplace transform of the simple function. So before going to solve the ODE, we should remember the Laplace of some simple function. So what is the Laplace of 1? 1 by s. Same thing, what is the Laplace of 2? You can take what is the Laplace of 2? 2 by s. The Laplace of 2 is 2 by s. What is the Laplace of e power AT? 1 upon s minus a. So same thing, what is the Laplace of 2 e power 2t? If you take e power 2t, that is 1 upon s minus 2. So like that, you know the common Laplace form, then you can